Hi, everybody. This is Carrie Goetz. Today, we're going to talk about the smart city side of IIoT. By the way, a little piece of trivia. If you type in IIoT, it will autocorrect to idiot, which is about what I think of that acronym. I think that when we talk about all of these connected devices, they all have very different needs, and lumping them under one thing is not necessarily productive. But let's talk about kind of the way they go. So we're going to talk a little bit about smart city, smart community, and the differences, why we have these, why it matters, urban versus rural needs, because they're very different, connectivity for all of these things, edge data centers, and some driving applications. So from a smart city, smart community standpoint, the definition and applications, like I said, really are across the board. For us in this presentation, as far as I'm concerned, it's a collection of applications and devices that use common infrastructure, data centers, and device level data repositories for communication of critical and non-critical information. So that's kind of a mouthful, but really what that is the ability for all of these different communications and sensors to talk to provide us the best outcomes. And why? Well, certainly the quality of residents and businesses in those communities is a big part of that. Communities that have turned up smart solutions definitely have more satisfaction, and that attracts new businesses, that keeps people in the town and keeps them from moving away. And it also provides a lot of much needed services, anything from healthcare to schooling, everything. And we've certainly learned that through COVID. It also provides a lot of intelligence. So cities that implement smarts become smarter about a lot of things. You can find out about leaks before they happen. You can certainly loop in fire, life safety, a lot of those things. And then we can also look at our carbon footprint. And that's anything from the lighting that we use, how we charge, where traffic goes, transportation, public transportation, figuring out, we can do heat footprints and see that at this particular bus stop, there's really not been anybody there because there's no heat signature for big portions of the day. So maybe the bus doesn't stop there, or maybe we change the route completely. And then we can also provide interactions between systems. So we know from one system to the next, some cause and effect. Again, that transportation is a really good example. Smart metering, so residents can look and see how much they have on a day-to-day basis. A lot of the utility companies will tell you the reason that people skip out on a bill is because it shows up as a big surprise at the end of a month. And so this way it gives them the ability to tap into their own meter and see where they're going, where it doesn't end up as being a surprise. So maybe they can change temperatures. With COVID and beyond, we've certainly learned a lot about edge compute. And it's one thing to say that you've got a data center, but if it's halfway across the country, that in a lot of cases in the COVID world didn't really help us any. So we're seeing more of these edge solutions and a need for those. Part of that is remote work, certainly getting that digital divide decreased, and we'll talk about that. Telehealth, telemedicine, remote learning, all the consumer services that happen. Right now, the estimates are that it's about $80 billion to close the digital divide just in the United States. 42 million Americans can't purchase broadband internet. And we have about 1 million Americans that have zero access options at all. No slow boat, no dial-up, no nothing. And so we know that we've got work to do. And, when people got confined to those houses, it certainly hurt them. And that's part of the reason a lot of people are moving to urban areas. According to the UN, 70% of the world population will be urban by 2050. And the digital divide is definitely real, and it's causing a lot of that. People are moving to cities because they have better access to other things. And, even in some of the big cities, access is not ubiquitous. You have bad spots in cities, you've got spots where, things don't work. And physical connectivity really only goes just so far. This diagram is from the World Cloud Initiative, and I really, really like this one because it really showcases a lot of the different technologies and the means that we have to connect. So whether it be satellite, whether certain things go to the cloud, if it's a local data center, if there's, something that maybe we're monitoring grain silos, and this could all go back to a university to study some of what's happening for, maybe an agricultural program. And we can look at crops, and we can determine how much moisture is in the soil. We can put temperature sensors in the roads and know when we need to dispatch salt trucks because they're frozen. There's a lot of things that really come to good out of this, and tech for good is honestly my favorite part of tech. From a city and community standpoint, planning is a big part of that. And so one of the things that you have to do is figure out the justification for this. It's nice from a city perspective to say, well, we're going to turn this up because it's going to make our residents happy, but there has to be some payback in that investment. And so part of that is things like savings on the street lights, because we can turn those on and off based on traffic and foot traffic, moving to LEDs as opposed to sodium and some of the other, heavier technology, being able to turn up charging stations around the city so that when we implement new electronic vehicles for the city, they've got places to charge kind of anywhere. It can also increase the revenue for the city. A lot of these services are things that the city didn't charge for before, and so it can become part of that. So for instance, a city could say, we're going to turn up LoRaWAN across the city. You'll be able to tap into your water meter, your gas meter, your electric meter, see what your usage is. You can put leak detection in your house. You can do all kinds of different things. You can tie it into your security system. So if you're getting a spike in your water bill and nobody's supposed to be there, you can check and see if you have a leak, or you can flip your security system on. So there's a lot of things that happen when we start tying these things together. Certainly some of the older cities have the benefit of being able to turn up fire in old buildings and do that wirelessly without having to run big clunky fire alarms. And then, supporting events and making sure cool things happen. And so as cities turn these services up, people want to move to the cities because they have all the power of these services. Businesses want to stay in the city because they know that the city is taking care of their business interests. If the business does well, the city does well. Resident interest, like I said, is a big thing. That prepaid utility service is huge. Being able to monitor and just know, that your light bill's getting really hot because it's summer, so maybe you bump the thermostat up a few degrees, or wirelessly connect to your thermostat because you're not there and turn it up 6 degrees or 7 degrees so that you can help better manage that light bill. Leak detection. With businesses, I've talked a little bit about the integrated fire systems, but again, they can do the same utility monitoring. They can enhance their security measures. They can, provide security to the city. They can share in the shared security for areas around the business. Open Wi-Fi, so people can have Wi-Fi available, and that also keeps them off the city Wi-Fi in some cases. For funding options, tax is certainly one, tax and bonds from a city and county perspective. When we get out to the rural areas, though, it's a little bit different. And so we have some acts here in the US through COVID, and we're seeing these pop up certainly all over the globe to try to get more connectivity to rural areas as everybody is quarantined and told to shelter in place. Some people couldn't work. Some people couldn't get their kids educated. And certainly in rural areas where there's not a lot of buildings and not a lot of connectivity anyway, that's an issue. Here in America, we have the American Connection Project. We have Broadband Now, there's state funds, there's public-private partnerships, and to be fair, those from everybody that I've talked to, and certainly all the work I've done in this area, the public-private partnerships tend to be really, really successful because there's something in it for everybody. There's a learning environment to be had. There's a lot that's gone really well with some of the universities, especially the ones that have agricultural programs and IoT programs on the IT side, trying to figure out some of this technology. They can team up and make some really great things happen. But you can see just for the Connection Project that was started by Land of Lakes, look at the number of companies that they have, and those are all visible companies. People know these names, and I think we're going to continue to see this all over the world, and certainly a lot of these companies are global anyway. So when we want to start down this, we really want to start with an RFI cycle. We want to reach out to the community. We want to see the kind of things they would like to see. We want to figure out who might want to pay for it. Sometimes you'll find corporate sponsors that might want to pay for that. You'll find partners in the industry. You might find a cellular partner that wants to be part of that. And then we can do a lab of things where you open a lab and figure out, let people come test things out and see what works, see what doesn't work. And again, this is a great way to really pass on some of this knowledge for support later on with the colleges and universities. You can have an innovation platform that really is a living lab. Some of the airports have done that, and that's how they've gotten some really great technology in airports. And just remember, you know, as you start down this path and you think about this, the discovery cycle is very, very important. There's nothing worse than, you know, the shoot, aim, ready, fire thing where it all is in the backward sequence. We want to make sure that we're putting in stuff that's going to work and that we have a clear understanding of need, and also that we give ourselves time just to sit down and figure out from a city services perspective what might be short and what might be, you know, what we need to beef up. And certainly fiber will be one of those things. A lot of cities have fiber in the ground, but they don't have fiber in the right spots. They don't have the pathways for fiber, might be another consideration. Coax would be certainly the same way, and copper. And depending on the copper, there's certainly distance limitations that are available, I mean, that are seen there. And from a fiber perspective, some of the cities that have done some really cool things, and by the way, all this is in a white paper. If you want it, I'll give you my information at the end. But some of the cities that have been most successful have done things like, if they have somebody that wants to pull 144 strands of fiber, then they come back and say, okay, well, you then pull an extra 24, we'll pay you for it, but at least it's all being pulled at the same time. So instead of having labor twice, they have labor once. And so it works out to be a good public-private partnership there. Cellular is part of this equation. We see a lot of talk about cellular, and certainly 5G there's a lot of talk about 5G, which is the next best thing until 6G comes along. But there, you know, a lot of that hype is coming from the fact that it's going to take different radios on both ends, which means a lot of device upgrades are going to be needed to be able to take advantage of that 5G infrastructure. And then Wi-Fi is part of that. We have Wi-Fi turned up in a lot of cities. Sometimes it's sporadic, sometimes it does better. And we have new wireless technologies with Wi-Fi 6 coming up. LoRaWAN has been turned up in a couple areas in Europe, all over the country. Here in the US, we have, like Nebraska is turning it up statewide, but there's definitely benefits to that. It's a little bit newer technology, so I am going to talk about that a little bit more from an edge perspective. And then we have NB-IoT, which is also another broadband technology. So if we go back to this wonderful diagram here and look at all of the different means to communicate, if we just take the communication lines, like I said, we see satellite, we see Wi-Fi, we see cellular, we see literally every mix in here, and the LoRaWAN and all of the other technologies coming together. We have solar farms that we can use, especially for, you know, to power some of the more remote things. Fiber, from a planning consideration, is a lot easier in a connected city than it is the connected rural area. It's very difficult for providers to run fiber out to, you know, a single business that's out in the middle of nowhere, because the payback on that is just, it's never going to be realized. And so in some cases, those businesses happen to be passed by fiber because it went somewhere else and they're on the fiber pathway. And certainly in cities, it's a lot easier for companies running fiber to recoup that cost. But out in the rural areas, it's just really not practical. In a city standpoint, from a city standpoint, we want to make sure that we do a fiber study, see how many dark strands we have, kind of get an idea of what we're going to need. And keep in mind, this is an iterative process. So there was a guy named Parkinson, and he had two laws. One was for bandwidth, and the other one was for storage. And pretty much what they said is, if you put it out there, they'll fill it up. And your fiber is going to be that way. As you start turning up new services and new cool services come along, and you want to add a little of that and add a little of that, add a little of that, you start filling up some of those things. And we can do different things with wave division multiplexing and other things, you know, to help the, help take advantage of all that we have in fiber. And some of the fiber, to be fair, is really old fiber that just won't support the newer protocols and newer technology. So it is important to check the fiber and see what you have and make sure that the fiber is going to support it. For wireless options, keep in mind, anything wireless still requires some type of uplink or connectivity at some point. And we have different possibilities because different things go different distances and support a different amount of connections at the same time. And some of these protocols may not be Ethernet, or at least not at the edge. They might turn to Ethernet at the uplink. For cellular, we have 4G, which is kind of in a lot of places now. 5G, like I said, that's the next greatest thing until 6G. Some of the more developing countries are still lagging behind on some of those, but cellular definitely provides some benefit there. LoRaWAN, I'm going to touch a little bit more on in a minute. Wi-Fi 5, Wi-Fi 6, CB, all of those have to deal with a certain cell size and figuring out connectivity, the number of channels. So there's some intricacies there, and that definitely takes a little bit different kind of planning than on the fiber side. And again, these are also going to be iterative. And whatever you do, whether it's connected fiber or it is wireless, keep in mind that all of these strategies have to be secure first. Just because a protocol is secure does not mean the end device is secure. So you really have to address security end to end across any of these solutions. So different factors when we talk about the wireless side, the distance that we're going is a consideration. You can't, wireless doesn't run forever. And the number of connections and the connections that we pass, the priority. So in a smart city situation, for instance, if you turn up Wi-Fi all over the city, you certainly want to make sure that anything that is life safety gets a higher priority. You want to make sure that city services get a higher priority. And there's products out there that'll do that too. We also have to think about signal loss, and that could be due to attenuation over distance, or that could be simple things like, signals don't travel really great through old granite buildings. And so we have to figure out something different to do to support the same services inside that we support outside. Movement of people from one antenna to the next and how that handoff happens. A lot of that was proprietary for a long time. And so as you start these projects, you want to make sure that you can have handoff from different manufacturers so you don't lock yourself into a single manufacturer solution. Reach is going to vary, and you might have an antenna or a technology that has a really great reach, but if you put a 100-story or 50-story solid concrete building in the middle, the signals don't go around that very well. And they don't travel through low-E glass, which is why you see a lot of these DAS projects popping up. And all of that is part of that multipath and fading. And then again, density, how much are we going to need from a public park versus how much you're going to need going down a street, or maybe in a smart bus enclosure where you have a lot of folks that gather in the morning. You want to make sure that you can support all of those, because honestly, if it's not usable and people keep getting kicked off, then you're just kind of wasting your money. So LoRaWAN is a newer technology. It's a low power wide area network, and it converts radio frequency signals to IP at the gateway. And it is one of those encrypted protocols. So this really addresses the protocol and the devices. And again, you want to make sure that your device is secure at the end, but this is a device to infrastructure type protocol. So it's not, there's only one hop between any device and any gateway. It also allows for firmware over the air upgrades, which is really good, especially if you think about agricultural settings where you have sensors out there in the middle of fields, in the middle of nowhere. You want to make sure that you don't have to run out to each and every device and plug in to do the upgrades and the firmware upgrades. And so that single hop really helps you there. Also, all of these devices are optimized for battery life, another important quality if they're going to be strung out all over the place. Network capacity, so they do very well from a communication standpoint. There's not a lot of overhead there. The range, they operate over that long range. That's the LoRa part. They are relatively inexpensive. I think as more and more of these devices pop up, you're going to see the costs get to be very, very reasonable, even though a lot of them already are. And then there's certainly a ton of variety. Companies that are writing to this LoRa protocol are growing every day. And these do everything from, I've seen smart cities use this for their smart metering technology. This works in smart agriculture where they want to see what the nutrients are in the soil or what the moisture levels are in the soil to determine whether or not to turn on the sprinklers. You see this for all kinds of stuff. And you can see some examples here, pet tracking, knowing where your dog is in the dog park, and smoke alarms. One of the old cities here in the US did LoRaWAN smoke alarm detectors in all of their old historic buildings so they wouldn't have to run cables for those. Water meters we talked about, trash containers. So the trash container tells you when it's full and when it needs to be emptied, vending machines. I mean, the list really goes on for the things that you can do. And 5G is different. It's not all the same animal. So there's a low, medium, and a high frequency band for 5G. And some of those are going to be reserved bands, and the radios and receivers certainly vary for that. NB-IoT is part of the low frequency side. And then we have an LTE that can be used for IoT devices over the low power wide area network. Power consumption is expected to be vast with 5G. There's going to be towers all over the place. A lot of the edge data centers accompany those. You see that with the containerized, in the shipping container data centers that pop up under cell towers. And, there's new spectrum being opened up for this because you can only cram the airwaves with so much. And we have so many devices, we're already cramming the airwaves. And these can also offload to unlicensed spectrum like 2.4 and 5 gigahertz here in the US. And certainly those spectrums are available, different spectrums around the globe. From a data center perspective, we have two types of communications with IIoT or IoT, both. And so some of that is machine-to-machine communication. It doesn't really need to go anywhere else. It's one thing talking to another. A good example would be if you're programming your thermostat. That communication is between you and the thermostat. It doesn't need to go to a data center. It doesn't need to be stored in the cloud. If you look for things like smart agriculture and precision agriculture, there's tractors that will drive themselves around your field and weed your fields, and nobody has to be in them. And maybe they hit something, and so then you turn on a camera so you can see what's happening, but you're not recording all of that camera footage, at one time. So there's different things as these compare and how long you want to retain that data. Maybe you're just retaining a solution set. So it really depends on the application, what those data center needs are. But those data centers, especially for the low latency stuff, you don't need a data center that's halfway across the country. And that's where we're really going to start seeing a lot of these edge data centers pop up. And there's some benefits to the edge side of things because it's a much smaller environment, so it's much easier to control. It's easier to provide, and less expensive too, to provide sustainable energy to power those. And they can be very easily replicated. And for a long time, we've sort of ignored the IT side of things when we look at building data centers, and it's all about how much power we give to them. But the IT side self-heals. And in many, many applications, it's an automatic failover. And so as we start distributing these edge data centers, if we have an application that's replicated around 10 data centers, we can really save some money and save a lot of the transmission costs because they don't all need multiple transmission paths if the IT load is going to fail over anyway. And so you see sort of a co-location on-premise type of thing for some of these providers that want to build edge data centers that can be used for rural healthcare and rural agriculture and rural community backups or rural community applications as far as that goes. And now keep in mind, local, state, and other regulations might really trump your business needs. So just because you need it doesn't mean you can put it out there, but certainly we're seeing a lot more cooperation between the two. And from an edge data center perspective, containers, which are the shipping containers, you'll hear the term ghetto colo, but that's what they are. They sit a lot of times under cell towers. They're self-contained units. They have the power, cooling, and everything. They do have a limited amount of space because there's only so much you can ship inside of a container. And so sometimes you'll see multiple ones of these on the same site. You can also go modular, and modular could be precast construction. Sometimes it's metal buildings. And I will say this, from the modular perspective, they all have different benefits. And when you think about edge data centers, they're not all going in the most pristine, risk-averse conditions. And so, sometimes we have to deal with hurricanes, tornadoes, and different cyclones that might impact where that data center sits. And so we want to be able to, really look and study the environment and make sure that we're putting in the right building for that environment. to make sure that, because if it's out there and nobody can get to it, it's going to be very difficult, if there's a natural disaster. So we certainly want to pay attention to those and pick the right solution for that. Sometimes they can be powered in different ways. Like I said, because they're a smaller footprint, renewables are certainly an easy way to provide some of this power, whether it be, wind, solar, whatever. And because it's a smaller environment, they don't consume as much power. So again, the equation to make that happen is much easier on a smaller scale. And I think we're going to see a shift. I don't think the colos are going to go away and the large data centers are going to go away, but we're definitely going to start seeing a lot more of these smaller data centers. And, everybody says that, it's not just me. But anyway, security is certainly going to be a different equation. We want to make sure that because these are going to be out in the middle of nowhere in a lot of cases, or areas that are not readily accessible, that they're, the security itself, so we don't have bad actors, we don't have animals going in there and causing problems, which happens with a lot of rural substations, by the way, and just making sure that the environments are protected. So this is all of my contact information. I'm always happy to connect on LinkedIn. You're welcome to shoot me an email. I do have a white paper that goes into all of this in much more detail than I've crammed in this little 20 minutes, but I hope to hear from you all soon. Thanks for tuning in.